I made a video yesterday. I was telling you yesterday the use of PV. This photovoltaic thermal solar air heater. So we I evaluated we evaluated the performance. Of course, we've done some measurements, and I said I dis discussed about the potential use of this system. Some of the uses are that the use of hybrid photovoltaic thermal, maybe for short PVT, solar air heater in the tropics such as Nigeria and Africa at large, enables the simultaneous production of heat and electricity, thereby making it possible to achieve high energy savings for space cooling. For instance, thereby making it possible to achieve energy savings for space cooling. For instance, it can be directly used by desiccant air handling unit. This photovoltaic thermal, that's PVT results, the results I got during my measurement showed that this PVT is good for supplement. It's a good supplement for electricity, and it's a good supplement for electricity generation, and it provides thermal heat gains for heating, for drying, cooling, and even an industrial process heat. This system, such a system like this, is appropriate for installation in dwelling, office rooftops, and buildings, and building rooftops of offices and buildings. Where the use of where there may be where there may be surface area limitations and the demand for both electricity and for either space cooling or for water heating. So PVT, this photovoltaic thermal air heater, of course, could be used for agricultural applications, maybe cooling of offices in the farms and the production of hot water for treatments, hatching of eggs, brooding of chicks, drying of crops, drying of leaves, and fodder for animals like goats, pig, cows, rabbit, fish, snails, and so on. It could be used for industrial process heat for canning of agricultural byproducts. Its application in agriculture will help, of course, boost some economy, especially some economy that based on oil, such as Nigeria and so on, some other countries that way. Of course, though its initial cost could be enormous, the initial cost could be enormous, but it could stand for the test. It could stand the test of time, since it has potentials for lower life cycle unit energy cost than, for instance, separate PV and solar thermal, separate photovoltaic such as this, or solar thermal such as that, ordinary solar thermal system. So generally, better output results from this system, this solar air heater, are used in solar energy. Of course, if you look at this system, of course, you can see the light it generates, the DC electricity directly from the battery. Of course, we have a switch here that's connected to the battery, but it's such that something burnt in it, so we connected it directly to the battery, you can see. Then we also connected this to the inverter. This is another way of generating the electricity from inverter. You can see the extension here connected to the inverter. You can see the inverter. You can see the inverter there. Then you can see the phone charging. Of course, this is the inverter. Of course, the other way is the charge controller. The charge controller is beeping because there is no sun here again. This is around 6 or after 6. This is a switch from the battery. You can use it to charge phones. You can use it for powering of electricity directly from the battery. But it's like we put it off and connect it directly from the battery. But this is a switch that goes directly to the battery. Then, of course, this is the battery. This charges. This goes directly to the battery, and this controls the charging. And from the battery to the inverter, if you need a electricity of 240, a neat electricity of 240 volts. From the battery also, we have we measured the temperatures using this measuring thermometer by using thermocouples, maybe K-type thermocouples, and some other thermocouples can be used. That's type K, type T thermocouples can be used here. You can see this thermocouple meter. The temperature now is 26.4 to tell you that it's already 6 or after 6. The sun is already set. It's 24.4 degrees centigrade from the ambient or otherwise. Of course, these are connections that are made here. Of course, this electricity here from the mains, from the inverter, 240 volts. You can use this, the 240 volt from the inverter. You can use the DC electricity from the battery. Of course, we also use some data logger. The other one is being amended. I have 2 data logger for this, but the other one is being amended. The other one that can measure. The other part. This measures from the control board here. If I switch it from here, if I switch it from here,
it's on.
You can see from here that
Not that one. The other one, the blue one is for it.
that's this blue one. So let me see if I can do some. The switch here. Pause it. The data logger. You can see it's on, though the LCD is down because of the sun. Maybe it's no more showing some values, but the data logger is working. So it's being connected to this board. And it's being connected to this board, and you can see it's working. Sometimes you can troubleshoot this data logger by the use of this cable. We use this cable. You can see the Arduino here, the Arduino for the troubleshooting. So this is the program for this. So you can change date, you can change time, or whatever you want to change by fixing this and troubleshooting from the laptop here. You can troubleshoot from here. Okay. So that is the system. Then you can disconnect. You can disconnect from this flex here from the board. The flex here went to this this data logger, so you can disconnect this flexible wire, this flex, or I don't know that you can call it jumper wire, but maybe the real name could be flex wire from this board. It's connected to this board. Then this board is connected to this photovoltaic system for measurement of temperatures. So, and that is how the data logger works. This data logger works. There are some other, of course, there are some other thermometers that were used, like this. Can you see the thermometer for measurement? We also use this relative humidity meter for measurement of humidity, possibly for this dryer. For this dryer. Okay, and we also made use of some instruments. We made use of some instruments like the hand tech. We use this pressure meter for measurement of the pressure inside this system. This pressure meter. We also use this hand tech for measurement of voltage and current. We also made use of this meter for measurement of current and voltage and power. And we also measure the insulation by using the instrument, this solarimeter. This solarimeter we use because this anemometer was used for measurement of this airflow in the fan. And one other instrument we also made use of was the solar meter. As you can see, the solar meter. We use it for measurement of insolation. And the fan is also being connected, and it also gives some airflow into the system. So, and we also measure the airflow using the anemometer. Okay. We measure the airflow using the anemometer. Then we can connect the fan, and I think the fan is connected. The other flexible wire. I don't know. Where can I? So I think the fan can be connected from here. You can see the fan is connected. Can you check the fan? So that's of course the air that comes out here is used for drying of materials in this dryer. So that's the system. That's all about the system. The hot air comes out here and it's used. You can see the link used for the drying. It's used for drying of some produce that kept in this dryer. So that's the system. That's the photovoltaic system, which was used as a research. Is used for research, for PhD program, and it's also used for research. Students are also using it for their research. Thank you.